The graph shows the amount of a medicine M in milligrams remaining in a patient's body 8 hours after receiving an injection. The amount of medicine decreases exponentially. So find the decay factor per 1.5 hours. So the decay factor per 1.5 hours. All right, so to figure that out, we need to do 153.6, and we need to divide that by 200. So 153.6 divided by 300, excuse me. 300. So 0.512. 153.6 divided by 300 is 0.512. So that is my decay factor per 1.5 hours. Find the decay factor per half hour. So per half hour. So let's first do our equation per 1.5 hours. So if I fill in the formula there, my initial value is 300 times 0.512 to the power of x. Okay, so x is going to be the number of 1.5 hour time periods. All right, so we've done this numerous times already. So if I plug in x equals 1, that means how many half hours? So x equals 1 means 1.5 hours. So that means 1.5 hours is 3 half hours. Okay. X equals 2. Okay. That means x equals 2 means 3 hours, which is 6 half hours. So on and so forth. So I have to take the number of half hours and I have to divide it by 2. So my equation, let me write this over here, per half hour is going to be 300 times 0.512 to the power of h over 3, where h in this case is number of half hours. Okay, because I have to divide the number of half hours by 3. So now I'm going to take that equation, 0.512 to the power of h over 3, and I'm going to play that algebra game again. So I'm going to take the h over 3, and I'm going to break that down into 1/3 times h, which means this right here, 0.512 to the power of 1/3, that is my decay factor per half hour. So decay factor per half hour is 0.512 to the power of 1/3. Okay, and that is it for number 7, and that is it for the study guide.